So this is how confidence intervals are created, visually speaking, okay? And this is how we come up with all of this information. Now, again, remember, most of the time a computer is going to kind of do a lot of this work for you, but this is how it kind of works. So you have a population up here somewhere that you have some interest about. Maybe you want to know the mean of something in that population. So you have these unknown parameters, P, mu, sigma, median, minimum, maximum, IQR, whatever it might be. You want to know something about this population. So you don't have time to take a census, and so what do? You take an SRS of size N. You take a simple random sample out of that population of size N. And what do you do when you take that simple random sample out of that population? You calculate the statistic that estimates the parameter of interest. Say what, huh? Here's what I just said. You take a simple random sample of some size out of the population, and if you want to know some parameter P, then you're going to calculate a P hat of your sample. If you want to know something about a mean of the population, then you're going to calculate an X bar from the sample. If you want to know a standard deviation of the population, you're going to calculate a standard deviation of the sample in order to estimate that. So you got your simple random sample, you calculate your statistic, and then you put that statistic on a dot plot or a distribution that you're basically creating. So let's say the first one goes right about there. There's your X bar. Let's say we're estimating a mean of some sort. So we have an X bar, okay? Now we go, all right, cool. Do you think that that X bar is going to be exactly the same value of the mean in the population? Probably not. Why is there going to be a little bit of a difference? Sampling variability. So we go, you know what? I wish I had a little wiggle room for my guess. And so what do I come up with? I come up with a margin of error. That's my wiggle room. How far do I think I might be off? And I allow myself that margin of error. So this is my margin of error. I add a margin of error, and that gives me a high estimate for the true mean of the population. I subtract the margin of error, and that gives me a low estimate for the true population value. And now I have an interval. This interval has hopefully captured the true mean for this population. Now, this particular interval, this first one, does it capture the true mean? Well, it looks like the true mean is going to be right here, right? So this one does capture it because it goes across where the true mean is. So what do? Well, did we get it right? We don't actually know because we don't ever get to know what the true value is. Just to remind you, you don't know what the true proportion of red beads is. So you don't know if you got it right. So, what might we do? Repeat again. We do it again. We repeat. We get another X bar. Maybe this X bar is, I don't know, right here. And there's my point estimate right there. And I, again, allow myself that wiggle room. And there's my interval of possible true values. Did this confidence interval capture the true value? Yes. It sure did because it crossed right where it is supposed to be. But did we know that for sure? No, so we do it again, and maybe we go and get another sample, and maybe the X bar this time is right here. We allow ourselves some wiggle room. On this one, again, we captured the truth, but we didn't actually know if we did, so we do it again and again. How many times do we do it? Wow, that's such a great question. That is such a great question. You know how many times you should do it? Until you have a normal distribution. Well, how many times is that? Well, it depends. I don't know. It's a lot. It's many, many times. It's a lot. Okay? Now, here's one thing I do want to show you real quick. Look at the 5th time that we repeat this process. Look at the 5th time that we repeat this process. We get a crazy point estimate that is way down here. And what happens with that interval? Did that interval capture the true mean? It missed it. Now, all of the other ones that are simulated to happen over and over and over again, all of the rest of them captured the true value and did a great job. Fantastic. Perfect. So, here's what we do. 24 of the 25 that we're done here. 24 of the 25 intervals captured the true parameter. Why does that matter? Well, what is 24 divided by 25 as a percent?
96.
Is it?
Yeah.
Guess what? We can now say that we are 96% confident that we have captured the truth. Because 96% of our 25 trials did it. That's where the confidence level comes from. Okay? So that is a picture of what we're doing. What questions do you guys have? All right, I have really good news for you. No, we're not done. We're just getting this party started. The good news is you guys don't have to do this over and over and over and over and over and over and over again. Okay? You just have to interpret what you're told in the problem from it being done over and over and over and over and over again. All right. I need you guys to take a trip back in your brain to chapter 3. Does anyone remember what chapter 3 was about? It was right after normal distribution. It was before probability. That was chapter 2. We didn't do trigonometry. Good guess. It was something that seemed a little bit kind of out there. Wasn't Z-score. The one where we had to write a lot of sentences, scatter plots, interpreting scatter plots. It was the linear regression unit. Does anyone happen to remember the sentence for interpreting slope? For every increase of 1 in the x, there would be a whatever in the y. Does anyone remember the sentence for interpreting the y-intercept?
For every increase in the y.
Nope. That was a good guess, though. Y-intercept. What is a y-intercept? Y-intercept is when x is 0, the y value would be whatever. Okay, cool. Does anyone remember the sentence for r squared?
The variation and...
It is the percent of the variation in the y that can be explained by the linear model relating the y to the x.
I don't even remember being
R squared. It will be on your next test, by the way.
really just like...
Oh, yeah, I'd do that to you. Now, why am I talking to you about sentences? Ladies and gentlemen, I present to you the statistical golden sentences. These are the 2 most important sentences that you will learn in your life. Ever. No cap. All right, so, especially this top one. This sentence is going to be a sentence that you will wake up at 3 o'clock in the morning and be like, oh my God, why am I waking up thinking of that stupid sentence? You are going to know this sentence very well, I promise. And here it is. When we need to interpret a confidence interval, here's how we do it. We are blank percent confident. That's the interval from blank to blank captures the true blank of blank. That's quite an empty sentence. What goes in the blanks? We are C percent. C percent is the confidence percent, the confidence level that you are. We are C percent confident that the interval from low to high, this is basically your low estimate to your high estimate, captures the true what? This is going to depend on what you're doing. It's whatever your parameter is that you are doing in that particular problem. Is it P? Is it mu? Is it something else? And then you're going to insert context of the problem. Are you talking about U.S. adults? Are you talking about teens in McKinney? Are you talking about fish in a pond? Are you talking about horses on a ranch? What are you talking about? That's what goes there. Cool? Cool. Yes. C is your confidence level. So what percent confident are you? Like yesterday when we were doing the beads, how confident you were that your answer was, that would be your C. Yep. All right, now that's how you interpret the interval itself. Now, how do I actually interpret this whole C? Where did C come from? So, this is where C comes from. If we take many samples of blank using the same sampling method about blank percent of resulting intervals will capture the true blank of blank. Okay, what goes in the blanks? If we take many samples of whatever your sample size is. If your sample size is 150, you're talking about you're going to do many samples of 150, okay? Using the same sampling method, I do have to indicate that I'm doing the same method over and over again. About C percent. So, on our visual from up above, 96% of the resulting intervals captured the true parameter of whatever the context of the problem is. Those are your golden sentences. Yes, they need to be memorized. Here's the good news. Especially the one on the top. You're going to write that one so many times, it's going to be really hard to forget it. Yes.
So if we say one word wrong?
No. That's a good call there, Stone. You got to kind of just include it all in there. If you say just one little thing wrong, it's not going to be the end of the world. But I will tell you, there is one word that is extremely important.
True value.
That we are capturing the true whatever. The true mean, the true proportion, the true whatever. Those are kind of like key words that need to be in there. Yeah. All right, cool. What questions, comments, or concerns do y'all have? All right, at this point, I've taught you all of 8.1. We just got a bunch of examples to do. You ready? Let's do it. Let's do it. I love examples. Let's try it. Twitter. Anybody heard of this thing called Twitter? Do you guys even use Twitter anymore?
Yeah.
Okay, yeah. It's just so you can see all the drama in the world.
Illegally streamed
To illegally stream things. I love it.
like the Oscars and stuff.
Oh, okay, got it. Yes, I like it. All right, cool. All right, so the Pew Internet and American Life Project asked a random sample of 2,253 U.S. adults. Do you ever use Twitter or another service to share updates about yourself or to see updates about others? Of the sample. All right, so they took a sample out of the population of size 2,253. 19% said yes. Time out. What is this problem about? Means, proportions, standard deviations, or something else? Proportions. Very good. According to Pew, the resulting 95% confidence interval is this right here. What the heck is that mean? Here's what this means. They took one sample of 2,253 U.S. adults. They got a p-hat of 19. Do you think 19% is exactly the amount that use Twitter? No, why not? Sampling variability. Who said that? Good job. Nice job. All right. Sampling variability. That's probably a little off, so we give ourselves a little bit of a window. What's that wiggle room called? Margin of error. And this is the interval that I think the true value might actually be in. Somewhere between 16.7% and 21.3% of U.S. adults use Twitter. That's what this interval is telling you, okay? All right, what is the point estimate? What is the point estimate that was used to create the interval? How did you know it was 0.19?
That's like the, I don't.
You're absolutely right that it is 0.19, but why?
It's p-hat, so then the margin of error was like made to around it.
Yes! Yes, Ava. Ava is a genius, y'all. So look, how does the interval get created? We talked about this yesterday. The interval is created by, you put the point estimate in the middle, and then you go out from there. If the point estimate is 19%, then that's what's in the middle. Also, furthermore, can someone please average these numbers for me? Add them up and divide by 2. Just, real quick on your calculator, add those two numbers up and divide by 2. What do you happen to get? Shocking. Yes. All right, so 0.19. Okay. Now, I'm just writing this for your information, which is the exact middle of the interval. Oh. It is the exact middle of that interval. It is what was used to create said interval. All right, what is the margin of error? So, check this out. I got 0.19 smack dab in the middle. My high estimate is 0.213. My low estimate is 0.167. I had to use the margin of error in order to get to both of those numbers. So from 0.19 to the high estimate, that's the margin of error. Or from 0.19 to the low estimate, that's the margin of error. So that distance is the same. Any ideas how I can find out how far that is away? Subtraction. So, guys, what is the margin of error for this problem? 0.023. That is how much I had to add to get the high estimate, and that is how much I had to subtract to get the low estimate. Now, I want to show you guys one other notation that could be used. I could say 0.19 plus or minus 0.023. That is just a way to write the interval with the point estimate plus or minus the margin of error. So like right here, that tells you the point estimate and the margin of error already. In this problem, they gave you the interval and you had to calculate the margin of error. Sometimes they'll give it to you in this way and you have to go to the interval, which is what we're going to do on the next problem in just a few minutes. Cool? Cool. Now we get to write sentences. Yay! Interpret the confidence interval. Interval. We are, what are we? 95% confident that the interval from 0.167 to 0.213. What are we confident that this interval has done? Captures the true what? What did y'all tell me this problem was about? Proportions. Captures the true proportion P of, all right, who's this problem about? U.S. adults who use Twitter. Tweet. We are 95% confident that this interval has captured the true value. Hey, I have a question for you. Could it be that 22% of U.S. adults use Twitter? Could be. Why?
Because it's not 100%.
We're not 100% confident, y'all. We're only 95% confident. We have a little bit of problem here, okay? It could be that we might be wrong. Just saying. All right, interpret the confidence level. If we take many samples of 2,253 U.S. adults using the same sampling method about 95% of resulting intervals will capture the true proportion P of U.S. adults
Oh my gosh, it's like.
who use Twitter. Hey, do you guys notice that both of these sentences end the same way?
Maybe you should have given us more room on the paper to write.
Oh, I probably should have, but I apologize. Write small. All right, cool. If we were to take many samples of 2,253 U.S. adults, create confidence intervals in the same exact sampling method way, then we would have about 95% of those resulting intervals would hit that middle line that is the true value of the population, the true proportion of U.S. adults who use Twitter. Cool? Not cool? Why is it not cool? Fine. It's not cool. It's whatever. Guess what? Let's do it again! No, really, let's do it again. It's going to be fun. Let's do it again. I'm so excited. Here we go. All right, you guys. According to the American Community Survey, a 95% confidence interval for the median household income in Texas during the years 2009 to 2011 is $58,925, plus or minus 218. Time out! What is this problem about?
IQR.
Thank you, Zach. I'm so glad someone can read. What is this problem about, y'all? Median. Median.
It literally says median, y'all.
All right. Good golly, Miss Molly. Now, what's going on right here? What is the 58,929?
P hat.
That's not p hat because there's no p. It's not hex bar because there's no mu. It's not IQR. It's the sample median. That's just the sample median. It's the point estimate. It's the sample median. What is the 218?
Margin of error.
The margin of error. Let's go. All right. So, the point estimator that we're using in this problem is sample median. There is no notation for sample median, folks. It's not X bar, it's not P hat, it's not S sub X, it's not IQR, it's none of those. It's just sample median. That's the point estimator. And the point estimate that we have used is 58,929. Cool. Now look, I don't even know the sample size. I don't know how many they took each time. It doesn't matter. But that is the point estimate. That's the sample median in whatever the sample size was. What's the margin of error? This should be pretty easy. $218. Boom, it's right there. It's literally right in front of your face. Now, what's the interval? So here's what we need to do. We need to take that point estimate of 58,929. We need to add the margin of error, and we need to subtract the margin of error. So that means I need to add and subtract 218 from that middle point estimate in order to get my low value for my confidence interval and my high value for my confidence interval. So, what is the low estimate for the true population median? 58,711. That is just 58,929 minus 218. And what is the high estimate for the true population median? 59,147. That is your confidence interval. That is, you are 95% confident that the true median household, whatever, is between these two. So, let's write our sentence. We are, what are we? 95% confident that the interval from 58,711 to 59,147. What are we confident that that interval has done? Captures the true, now time out, I do want to make sure that I clarify, it is not the true sample median. I don't have to capture the sample median. I have the sample median. It was 58,929. What am I trying to capture though? I'm trying to capture the true median, the actual true population median. We're capturing the true median household income in Texas during 2009 to 2011. We are always trying to capture the true population value. We do not have to capture sample values because we have them. We took samples. We calculated them. Cool?
Are we done?
No, we're not done. We are not done. Why would we be done? We're just going to do this first part in the second page, the next page. It's fine. We've got this. It's easy. We got this. Here we go. The admissions director from Big City University found that 107.8 to 116.2 is a 95% confidence interval for the what? Mean IQ score of all freshmen. We need to discuss whether these explanations are correct or incorrect. Now, I do want to say something about our golden sentences. As Stone said a little while ago, they don't have to be word for word. We're not technically looking for a golden sentence here. We're looking to see, is what it's saying true or is it false? That's really what we're looking for. So here we go. Ahem. Is this true? There is a 95% probability that the interval from 107.8 to 116.2 contains mu. Is that true or false?
False.
False.
Think about that 95%. Where does that come from? Does that come from calculating a probability of something?
No.
Or does that come from what percent of intervals have actually done what it's supposed to do? That's what it is. It's not that there's a chance of something. The 95% is what percent of repeated intervals capture mu. So this one was false. Bad. Bad interpretation. All right. Part B. Is this true?
Yes.
There is a 95% chance that the interval from 107.8 to 116.2 contains X bar.
Yeah.
Is that true? Are you sure? This is false, you guys.
False.
Why is this false?
Because it captures 95% of repeated intervals.
Because that's the sample, not like the.
Okay, time out.
There's 100% chance that's in there.
Whoa! Nilu, please explain. Nilu just said there's a... was that Sydney or Nilu?
That was Milo. No, but she was explaining why.
Ah, well, between the two of y'all, explain. They just said there's a 100% chance. I'm sorry, what? You're right.
It all has to be in there.
Guys, where is X bar at in the interval? It's in the freaking middle. So what's the chance that the X bar is in the interval?
100%.
Every single time. Every time. X bar is going to be the center of every interval that is created for mu. So there's not a 95% chance. There's 100 freaking percent chance. There is 100% chance.
It's false, 100%.
Because X bar is the middle of the interval. Okay, how about this one? C. This interval was constructed using a method that produces intervals that capture the true mean in 95% of all possible samples.
True.
That is absolutely true, ladies and gentlemen. That is absolutely a true statement. That is exactly the confidence level interpretation. All right, let's look at D. If we take many samples, about 95% of them will contain the interval of 107.8 to 116.2.
True.
False. False.
It's not moving.
This is false. Why is this false, though?
Because it's asking for that exact interval, not
Because
like
it did say 2 minutes.
What are we trying to capture, y'all?
the true meaning.
The true mean. Am I trying to recapture this interval? No. 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 We want to capture mu, not a specific interval. Okay, this last one, I have faith in you. Think carefully. The probability that the interval of 107.8 to 116.2 captures mu is either 0 or 1, but we don't know which. The probability that this interval has captured mu is either true 0, or false, 1, whatever. But we don't know which. Is that a true statement?
Yes.
This is absolutely true, ladies and gentlemen. Here's why. Do any of you know if you captured the true proportion of red beads?
No.
But some of you did. Some of you didn't, but you don't know if you did. But every interval that we create either gets it right or gets it wrong.
What's up, bro?